What would happen if a system of refrigeration without electricity existed? The consumption of electricity and the pollution that it causes would be reduced. This project was born with the intention to make new technology, a natural refrigeration, something for everyone, something that could save thousands of lives, giving the possibility to bring refrigeration to the most remote areas in Colombia and all over the world, to the ones who need it the most but don't have it. For this reason, we created PseudoFreeze, which is a new way to refrigerate naturally. PseudoFreeze's first application is a fridge specialized in the storage and transportation of vaccines and medicines. It works with the creation of a novel bio-nano composite able to freeze at higher temperatures and a faster rate by enhancing energy from proteins. Our technology is characterized by the immobilization of ice nucleation active proteins in nanometal surfaces. We can provide different ranges of temperature by freezing different liquids like water, glycerol, and ethanol. We are able to reduce energy consumption and carbon emissions by refrigeration, not only because we need less energy to freeze, but also because we offer a cooling cycle from 3 days to 1 week that can be restarted with the same water and bio-nanotechnology. But wait! This is not the only scenario in which we can enhance refrigeration. You must be asking yourself about the coverage of PseudoFreeze. As we created a bio-nanotechnology that has endless applications, this opens our universe to design any kind of device for different applications in food, floriculture, mobility, and architecture. Given this huge panorama, we designed our first air conditioning proposal, creating PseudoFreeze's panels that basically work with the heat exchange principle, introducing our bio-nanotechnology and its maximum freezing volume capacity. This air cooling system is characterized by 5 milliliter cavities agglomerated in a panel, creating a chamber of slits where the air can seep and cool. Inside of each cavity, there is ethanol mixed with our bio-nano composite, and between each cavity, there are ducts, working with pressure changes. This system also has a last cavity that works as a drain for the thawed ethanol. When this cavity fills its capacity, the freezing cycle will repeat automatically, only by injecting the ethanol that is in the drain back into the system. This will generate an internal flow between each panel cavity and its duct. Finally, the airflow will be driven out by a fan, and this will be the only source of energy consumption of this novel air conditioner system. This way, we could guarantee less greenhouse gas emissions, saving customers money and reducing 70% of energy consumption by only using 50 watts a month, compared with regular air conditioning that uses 181 watts. But how could this bring sustainability to the aeronautic industry? Refrigeration in planes also works with heat exchange principle by exposing the warm air to outside cold air. Multiple steps of cooling and warming are needed to finally have an accurate temperature for the cabin. This is because of the extreme temperatures during flight. What if PseudoFreeze could provide a cooling device that continuously maintains the air at the exact temperature that the cabin needs? It could keep cabin air temperature at 20 degrees Celsius. Also, PseudoFreeze could replace the 2 air conditioning packs and provide more sustainable refrigeration, simplifying steps that air conditioners currently require. This could guarantee energy savings and less fuel burning by needing less compressors, valves, and mixers in the system.